We're looking at inequalities still, moving on to quadratic inequalities, this and rational inequalities. This is where things get a little more complicated, in fact, quite a bit more complicated. Because we can't just solve for x in the same way we had before. We get two different solutions. So how does that work? I'm going to move over to the document camera, take diligent notes here, and make sure that you email me with questions or message in the XYZ homework with questions as you have them. Okay, so we'll try the bottom one too, but we're going to concentrate on this first one right here. And I'm going to move over to the document camera. If we're going to solve this, first, it doesn't equal 0. So we can't use the zero product property. However, factoring it is going to be important. So let's factor this. 0. And we're going to factor, so we find two numbers. There's a coefficient of 1, the leading coefficient. Two numbers that multiply to 24 that add to 10. I'm going to go with, would that be 2, 4, 3? I'm stuck. 6 and 4. That'll work. 6 times 4 is 24. 6 plus 4 is 10. There we go. All right, so I've factored it. But again, x isn't just going to be negative 6, and x is not just going to be negative 4. However, we're going to kind of glaze over that for a minute. We're going to ignore the fact that this is a greater than. Technically, we can't just set these equal to 0 and solve because it's bigger than 0, not just equal to 0. But we're gonna ignore that for a minute. We're looking at x plus 6 and x plus 4. If this were an equal sign, so we're just going to pretend for a minute that this was an equal sign. X could be negative 6 and x could be negative 4. The only reason I'm doing that, because again, it's not equal to 6, it's not equal to negative 4, I want to be very clear on that, is if I'm going to set up a graph, our way, and this shows up in the textbook, shows up in other areas, our way of graphing this is to actually make two number lines. Now, this is not going to be our official final answer. We're just going to draw two number lines. I'm going to put these two, these are what we would call important numbers or key numbers or turning points in where our graph shifts. I'll show you what I mean in a minute. So we're going to put these two numbers on these two number lines. So negative 6 and negative 4, they do need to be in numerical order. So negative 6 is less than negative 4. Now, if this is going to be, well, actually, I take that back. Before I get to that, let's go back over here. What we're going to do now is we're going to say that any number that we plug in for, let's say, x plus 4, if that number is bigger than negative 4, so greater than negative 4, let's say negative 3, negative 3 plus 4. Negative 3 plus 4 is going to be a positive number. If x was 0, 0 plus 4 is going to be a positive number. So any number I choose for x that's greater than negative 4, it's going to give me a positive result here. Any number less than negative 4, so negative 5, for instance, negative 5 plus 4 is negative 1, it's going to give me a negative solution. So the pluses and the minuses here are just representing what type of an answer I'm going to get if I choose a number greater than negative 4 and I plug it in here. I'm going to get a positive solution. Less than negative 4, I'm going to get a negative solution. Same thing for negative 6. If I choose any number greater than negative 6 and I plug it in here, I'm going to get a positive solution. So negative 5, 4, etc. Those are all going to be positive. Anything less than negative 6, I'm going to get a negative solution. So the pluses and the minuses here are just denoting, and it's always going to be left is plus, or excuse me, right is plus and left is negative, right is plus. That's always going to work out to be true. It's just always going to work that way. Because if you pick a bigger number, it's going to be bigger than 0. Here's the important part here. Here's where we actually solve it. We want the product of these two to be greater than 0. So we want the product of these two to be positive. Well, if I pick a number greater than negative 4, I'm going to get a positive number for this part and a positive number for this part. A positive times a positive is going to be positive. So that is going to be greater than 0, that multiplication. If I pick a number greater than negative 6, but less than negative 4, so somewhere in between here, negative 5, for instance, I'm going to get a negative for this part and a positive for this part. A negative times a positive is a negative. I don't want a negative solution. I want a positive solution from this product. So that won't work. Keep going though. A negative times a negative is going to be positive. So that will work. Graphing them, my final graph here, this is going to be my final solution. -6, -4, not equal to 0. I don't want it to ever equal 0. I just want it to be greater than. So I'm going to use an open circle here. And if I go greater than -4, I'll get a positive solution. If I pick 1, for instance, 1 plus 4, 1 plus 6, multiply them together, greater than 0. Boom, done. And less than -6. Again, open circle, because it's not equal to. If I pick, say, -10, -10 plus 6, -10 plus 4, multiply them together, I'm going to get an answer greater than 0. So here's my graph. I graphed all the possible solutions to this quadratic inequality. My solution set then is I would say that x could be less than -6, and this would work. If I pick any number less than -6, I'm going to get a positive result. Or x could be greater than -4. You'll notice the or gave me arrows, and you can't really see my thumbs very well, going in opposite directions. They're sort of like that. So or is going to give us arrows going in opposite directions because you can't have a number that's less than -6 and greater than -4. It just doesn't work. And so or is when your arrows go in opposite directions like this. All right, let me do another example. So we have this one here, x squared minus 5x plus 6. If you think you've got this, if you think you kind of have a handle on it, try it on your own first. Pause it and try it on your own. I am going to go through it right now, though, because I know it can be very confusing. So I want to show it one more time. All right, so here is my quadratic inequality. So again, I'm going to factor it. Leading coefficient is 1. Two numbers that multiply to 6 that add a -5. I'm going to go with x minus 2 and, x plus 2 and x minus 3. Oh, x minus 3, x minus 2. Wow, look at me. -3 times -2 is a positive 6. -3 plus -2 is a -5. All right, less than or equal to 0. So I factored it. And again, I'm going to ignore the fact that I'm doing something that mathematically is incorrect. I'm going to pretend it's an equal sign. I'm going to say that x could be positive 3. 3 minus 3 is 0. And x could be positive 2. 2 minus 2 is 0. It's not an equal sign. It's not an equation. So those are not the solutions. But I'm going to use those two numbers as kind of a guide for where I'm going to find my turning points, those tipping points, and where things are positive or negative. I'm going to put those numbers on my double number line here in numerical order. And again, it's always going to work out that to the right of the line is positive, to the left of the line is negative. If I pick a number that's greater than 3, 4, or 5, and I plug it in here, I'm going to get a positive result. If I pick a number less than 3, I get a negative result. Greater than 2, positive result. Less than 2, negative result. So plus, minus. Now we have to look at this bit right here. I want a number, I want the product of these two to be less than or equal to, but less than 0. Well, a positive times a positive is not less than 0. That's going to be positive. A negative times a positive is negative. A negative is less than 0. That'll work. A negative times a negative is positive. That's not going to work. So the only possible solutions for this inequality here to work, where the product of these two is less than 0, is if I pick a number that's in between 2 and 3, like 2.5. Now it could be equal to 0, so I can pick exactly 2 or exactly 3. So I'm going to put closed in circles. I'll say anything in between. Now there's two ways you can write this as a solution set here. You could say that 2 is less than or equal to x is less than or equal to 3. You could write a compound inequality like that. Or you could also write 2 is less than, 2 is less than or equal to x and x is less than or equal to 3. Because that would say that whatever value you choose for x has to be greater than or equal to 2, and it has to be less than or equal to 3. It has to meet both qualifications. So that's how you solve graph and give the answer to these quadratic inequalities. Okay, almost done. Rational inequalities. So I'm going to do the one on the left here, and I'm going to ask you to try the one on the right on your own. So on the left, we've got x plus 7 over x plus 8. So we've got this rational inequality. Back over to my document camera. This is less than or equal to 0. It is the same idea. We're going to look at these two separately, except instead of multiplying them together like we were doing before, we're going to divide them. So x plus 7, I'm going to pretend this is an equal sign. X could be -7. -7 plus 7 could be 0. Or x could be -8. Okay, and that would be 0. So I'm going to use my double number line here. Numerical order, -7, -8. Again, greater than -8 is positive. I put these in the wrong order, didn't I? Sorry, -7, -8, there we go. Greater than -7, positive, less than -7, greater than -8, positive, less than -8. Now I'm dividing. So I want their division to be less than 0, to be negative. Similar to the last one we did, a positive divided by a positive is still positive. I don't want a positive result when I divide. I want a negative result. Negative divided by a positive, that's going to be negative. That works. That's less than 0. Negative divided by negative is positive. That doesn't work. So I'm going to have my solution set here. Or my graph, excuse me, my graph of the solutions. One thing you do have to be more careful of with division than you do with multiplication is this. You still can't divide by 0. Even if this says less than or equal to 0, you still cannot divide by 0. So if the numerator was 0, if this x was exactly -7, -7 plus 7 is 0, that would be okay, because it could be less than or equal to 0. That's fine. 0 divided by anything is 0. So x could be exactly -7. However, even though there's this less than or equal sign here, we cannot have x be -8. Because if x was -8, -8 plus 8 would be 0. We'd divide by 0, black holes would form, it would just be chaos. So even though this has a could be equal to sign there, less than or equal to, we still have to have an open hole there, because we don't want the world to implode. And anything in between. So I'm going to write it the faster way. I'm not going to use the word and. I'm going to say that x could be greater than -8 or less than or equal to -7. So I've graphed and solved that rational inequality. I'm going to challenge you to solve this one on the right on your own. Get a common denominator and try and work at it from there. See what you can do. Last one, word problem. A couple things to write down. At least, you see that word at least, typically means greater than or equal to, and at most typically means less than or equal to. Think about it. If you say, I need to make at least $100 this week so I can buy something. It'd be fine if you made $5,000. You made at least 100. So greater than is okay with at least. If you made it exactly 100, you met your goal. So or equal to. At most, I need to get at most 7 hours of sleep at night. Otherwise, I know I'm going to be crabby. I need to drink I'm not going to go that direction. Sorry. I'll go with the sleep. I need to get at most 7 hours of sleep. Then less than will be okay. I can get 6 hours of sleep. That'd be fine. Or equal to. That's maybe a poor example, but that's the idea. You tell your, I don't know. Okay, so that's at most. We have our example, a manufacturer, they're making portable radios, and they've got this equation for revenue, where X is radios given by the equation. Pretend that, and P is the price of each radio in dollars. What price should be charged for each radio for the weekly revenue? This would be at least $5,400. I take that back. I'm going to use a different example. I'm not going to ask you to do one like this because there's a secondary example in there. If you were to set this up and you would want to say, instead of talking about, I apologize. I read this wrong. We don't really need to know the number of radios for this problem. There is another formula that would be needed to solve for X and the number of radios. The question says what price? So we have this equation here for price, and we have a weekly revenue of at least $5,400. So let's work this problem out. I've got my equation. Revenue is 1,500 times the price minus 100 times the price squared. And I want the revenue to be at least, so greater than or equal to, it'd be fine if the company made $7,000, but at least $5,400. Okay, so 5,400, and it's okay if they make more than 5,400, but they can't make less. So 5,400 has to be the bottom, has to be the lowest amount. There we go. Okay. So I'm going to, I can't really solve it the way it is right now. I guess I could try and use completing the square, but I don't think that would work very well with an inequality. So I'm going to subtract 5,400 from both sides and get this. Actually, I take that back. I'm going to add 100p squared, and I'm going to subtract 1,500. I want to get it all onto the left side. So I'm going to add 100p squared. I'm going to subtract 1,500p. 100. I do notice, less than or equal to 0. I do notice that they all have a common factor of 100. So I'm going to factor out 100. It's a little bit easier. I'll divide away that 100. It becomes 1. And I did not divide by a negative, so I don't have to worry about flipping that sign. Okay. Now I need to try and factor it. So I need two numbers that multiply to 54, that add to negative 15. I think I should be able to get it with negative 6 times negative 9. That should add to negative 15. So I've got p minus 6 and p minus 9 less than or equal to 0. We're over here then. So again, assuming this was an equal sign, p could equal 6 or p could equal 9. I'm going to use that, or use those two numbers anyways, to help me figure out the graph. Greater than 9 positive, less than 9 negative, greater than 6 less than 6 negative. Okay. I want the product of these two to be less than or equal to 0. Less than 0 is going to be in here because a negative times a negative is positive. Positive times positive is positive. Negative times positive is negative. So 6 less than or equal to, because it is less than or equal to there. P less than or equal to 9. Because this is not a rational inequality, it's a quadratic, I don't have to worry about dividing by 0. So I'm left with my solutions here, and I would graph it 9. I would say that anything in between. So the profit that they need to make is somewhere in between $6 and $9 profit on each radio. So if they made $7 profit, they'd be good. If they made $9 profit, they'd be fine. And if they made $10 profit, I believe the problem ends up being that the cost to create the radios ends up being too much, and they don't make a profit anymore. That's why there is an upper bound on that. Okay, that's how you solve these inequalities.